and welcome to the video lecture on physical records. This is really the crux of physical database design. You have to realize that when you're designing your database, logically you're going to look at your data and you're going to see data stored in fields and records. What you really need when you're designing the database is you really need to have an understanding of what's physically happening on disk. And I'm not going to get into real, deep down specifics. I mean, this isn't a course in that. But you need to understand, what do I mean by a physical record? So when we talk about a physical record, that for all intents and purposes is synonymous with an instance of an entity. So when you talk about a record associated with a student, that would be the student ID, the student name, the student address, their GPA, whatever fields and attributes you had associated with that student. When we talk about a physical record, that is the physical record, all of the different fields. So when you talk about the physical record, you have to understand that based on the data types that you used, that record is going to have a particular size, right? So one of the things that you have to do when you're guesstimating and you're building your database is you need to come up with an estimate on what your physical record size is going to be for any given table. So, how many bits and bytes is going to be associated with the student, an average student ID, how many bits and bytes are associated with a student name, a GPA, and so on. And you do that for every field. You get an average physical bits and bytes size for a record. So when you say that you're accessing a physical record, that is, you're grabbing all of the fields from the memory locations. So for instance, and again, yep, here we go. This is, I think, is a better looking diagram of a disk. So say this is a disk and these are the sectors, and we're writing records. So when I write a student record, it runs about that big, right? And again, just bear with me, all right? So we're writing to disk, and that is a student record. And when I write another student record, it's about that big. And I write another student record, it's about that big. Obviously, this is, not the case, but, in order to illustrate what's going on. So we're writing our physical records down. We've got our physical records. So now you have a basic understanding of, or at least a cursory understanding of what's going on with your physical records. When we talk about a page, right? A page is, you can tune the database management system to talk to the operating system. And when it talks to the operating system and says, listen, I need data taken off of the hard disk, what's going to happen is you're going to tune the database management system to tell it to take a certain amount of data. So for instance, maybe your page size is a megabyte, right? And you've decided that every time I'm going to task the operating system with reading data from disk, okay, reading data from hard disk, when it's doing an input-output operation to a hard disk, how much data am I pulling? Right, so that gets into a whole tuning thing about, how often do I go to disk, and I want to minimize how often I go to hard disk. Why? Because hard disk, when I'm going to a hard disk, that is about 1 million times slower retrieving data off of a hard disk than it is out of RAM memory. Right, so when we talk about RAM, how much RAM is in the server, and then how much disk space, two completely different things. And when we talk about getting data out of RAM memory, it's virtually instantaneous, right? Because it's stored electronically. On hard disk, we're talking about the disk moving, right, spinning around, and a read-write head has to read the data off of this and bring it into RAM memory. All right, 1 million times slower than reading it out of RAM memory. So we want to make this happen as infrequently as possible. All right, that's when we get into tuning. So we want to set up a page size, and again, let's just say it's a megabyte of data. So if I'm pulling a megabyte of data every time I go to disk, what happens is how many physical records is that? And that's when we talk about the blocking factor. So if I've got my physical record, so I'm storing, let's just, again, to make this simple, I'm storing data associated with the student table. So the student table is associated with any number of physical records. So I want to pull data from the student table. When I do that, if it's not in RAM memory, right, if I don't have the student table stored in RAM memory, it's going to turn around and I'm going to have to read it off of disk. So when I read it off of disk, how many pages do I have to read? And that's going to be directly associated with the number of physical records per page. So if I have a physical record, if my student physical record is 5 kilobytes, right, I'm going to be able to read, right, so 5 kilobytes is a record, and you do the math. So 5 goes into 1,200 times. So I'm going to be able to read 200 student records every time I grab a page of data off of disk. Now, I may have millions of student or hundreds of thousands of student records. I may have millions of student records. In order to read those, I have to read multiple pages. So all of that is going to take time. So realize that when you're creating your when you're setting up your physical records, and and again, it's an advanced topic, but when you're tuning your database management system to figure out how much data is being pulled off of disk, keep that in mind. You need to know that. And that is the end of the physical records